It's black holes all the way down, according to John Coates' new theory. He claims will revolutionize our understanding of the harmful effects of man-made EMR pollution and our place in the universe, ushering in a new era of medicine. But we might have to think of space and time differently to do so. Let's dig in. Have you ever wondered what if time, as we understand it, isn't a linear progression of events, but rather a measure of changes within the universe? This question is at the heart of a new interpretation of time and space, known as the Genesis framework. Traditional physics often treats time as a sequential order of events. However, the Genesis framework offers a different perspective, suggesting that time is fundamentally a measure of informational entropy change within spatial dimensions. This intriguing idea implies that the progression of time directly links to how rapidly information is encoded into the universe's structure, a process governed by entropy's dynamics. To understand this concept better, imagine the universe as a vast ocean. In this ocean, there are two distinct types of spaces. The first, quantized spaces, are like water in its liquid state, filled with energy and exhibiting a measurable temperature. They represent high entropy states where time, as we experience it, ties to observable physical phenomena. On the other hand, non-quantized spaces are like ice, devoid of heat and energy, yet filled with stored information. These spaces represent low entropy states, allowing for a form of information storage that transcends the physical limitations we typically associate with time and space. In this framework, time dilation, a well-documented effect of relativity where time appears to slow down near massive objects or at high speeds, is reinterpreted. It's seen as a variation in the rate at which information is processed and stored. The closer an object is to a source of gravity, the slower time passes because the rate of information storage into non-quantized space is altered. The Genesis framework paints a picture of the universe where quantized space is akin to water in its liquid form, dynamic, full of energy, and in a higher entropy state. This state is where matter and energy interact, and temperatures can be measured. In contrast, non-quantized space is like ice, solid, unmoving, and colder, representing a lower entropy state where information is preserved in a frozen form. This space doesn't participate in the energetic interactions that characterize quantized space, but serves as a timeless repository of information. Just as freezing water transitions from a high-energy state to a structured, lower-energy state, the universe freezes information from the quantized to the non-quantized space. This transition is crucial for storing the geometrical and informational essence of the universe, much like how freezing preserves the structure of water in the form of ice. In this framework, the experience of time itself can be seen as the process of this freezing, where the laws of physics dictate the rate and manner in which space is recorded and stored. In the Genesis framework, time is redefined as the rate at which information is processed and transferred from the quantized space to the non-quantized space. As in our ice cube analogy, the freezing process represents the passage of time. This interpretation of time and space offers a new perspective on the universe's fundamental nature, providing food for thought for both physicists and laypersons alike. Learn more about the Genesis framework by John R. Coates, Jr.